Hello everyone, in this video we will learn all about implicit differentiation. To begin with, find the derivative of 5x cubed. Derivative of this is 15x squared, derivative of x with respect to x. So since dx over dx, you can cancel that. So final answer here is 15x squared. Another. Find the derivative of y to the power of 4. Now given this would become 4y cubed, derivative of y with respect to dx. Another. Given this, y squared is equal to 4x. So with this, we'll get the derivative of y squared and 4x. So derivative of y squared, that would be 2y, derivative of dy dx, then derivative of 4x, it's 4 dx dx, or simply 4. Now, dividing both sides by 2y, so we will end up with 4 over 2y, or simplified answer here would be 2 over y. Another. Find the derivative of x cubed plus y cubed is equal to 8. So given this, derivative of y cubed, that's 3x squared. Derivative of y cubed is 3y squared. Derivative of y with respect to x, and derivative of a constant, that's 0. Now at this point, we will transfer 3x to the other side, so that would become negative 3x squared. Dividing both sides by 3y squared, we will end up with dy over dx is equal to negative 3x squared over 3y squared. So since we can cancel 3, so final answer here is dy dx is equal to negative x squared over y squared. Okay, another. Given this, find the derivative of 36 is equal to the square root of x squared plus y squared. Now in this case, in order to eliminate our radical sign, we have to square both sides. So this would become 36 squared. So with this, what is the derivative of 36 squared? That would be 0. Derivative of x squared is 2x. And derivative of y squared, that would be 2y dy dx. So at this point, transfer 2x to the other side. And at this point, divide the entire equation by 2. So our final answer here is negative x over y is equal to dy dx. So take note, derivative that contains y is typical in implicit differentiation. Now, for implicit differentiation, there are basic steps that we need to consider. Number 1, set all y terms in the left side, then differentiate both sides, then isolate all dy dx terms on the left side. So for example, let's have more. So given this, find the derivative of x squared plus y squared minus 8x plus 2y is equal to 16. So with this, we will leave y squared and 2y to the other side, then the rest transfer to the other side. So we will get this. So at this point, get the derivative of this. Derivative of y squared, that would be 2y dy dx. Derivative of 2y is 2 dy dx. And derivative of negative x squared is negative 2x. Derivative of 8x is 8. And derivative of a constant is 0. Now at this point, factor out the dy dx term. So we will end up with dy dx. Then we will have 2y plus 2. Then the other side. Now at this point, divide the entire equation by 2y plus 2. So we will cancel this. So we will end up with 2 negative x plus 4. Then since we can distribute 2 to the terms inside, we go back to this. Then factor out 2 as well. So at this point, we can cancel 2. So the final answer is negative x plus 4 over y plus 1. So take note of this. Okay, another example. Now find the derivative of 5xy minus y cubed is equal to 9. So take note here, 5xy, we can make use of product rule here. So with this, what is the derivative of 5xy? So that would be 5x. Then derivative of y is 1 dy dx plus, you copy y, then derivative of 5x, that would be 5, then minus derivative of y cubed, that's 3y squared, dy dx, and derivative of 9, it's 0. Now at this point, okay, we'll get this. So group all the dy dx terms to the other side, then transfer 5y to the other side. That would become negative 5y. So factor out dy dx term here. So we will end up with 5x minus 3y squared is equal to negative 5y. Divide the entire equation by 5x minus 3y squared. So we can cancel this. We will end up with negative 5y over 5x minus 3y squared. Okay, another example. Now, given this, what is the derivative of tangent xy is equal to 10? So at this point, take note, the derivative of tangent is secant squared. Copy this, xy. Then get the derivative of the angle, or xy. So copy x, derivative of y is dy dx, plus copy y, then derivative of x is 1. Then derivative of 10 is 0. So simplifying this, you distribute secant squared xy to the terms inside. So we will end up with this. Transfer y secant squared xy to the other side. So we're left with x dy dx secant squared xy is equal to negative y secant squared xy. So with this, divide the entire equation by x secant squared xy. So you cancel this. So we will end up with, so at this point, you can cancel secant squared xy and secant x squared xy. So you can cancel that. So you're left with negative y over x. So take note of that. Okay, so given this, we solved this in the previous slide. So again, square both sides. We'll end up with this. So derivative 36 squared is 0. This is 2x and this is 2y dy dx. So transfer negative 2x to the other side. Then divide the entire equation by 2y. dy dx is negative x over y. Now, we can get the second derivative of this. So the second derivative of this would be d squared y over dx squared is equal to, so again, denominator times derivative of numerator, which is negative 1, minus, copy the numerator, and derivative of the denominator, that's actually dy dx, over the square of the denominator, which is y squared. So simplifying this, this would become negative y plus x dy dx over y squared. So simplifying this one further, so take note, dy dx is equivalent to negative x over y. So take note, we replace that here. So simplifying further, this would become negative y minus x squared over y squared. So simplifying further, so you cross multiply this, this would become negative y squared minus x squared over y. Then all over y squared. So get the reciprocal of the denominator, then multiply. So again, the reciprocal of y squared, that's 1 over y squared. So simplifying further, this would become negative y squared minus x squared over y cubed. This is the first and this is the second derivative. So take note of that. Okay, now let's have this. Find the slope of the tangent line to a circle x squared plus y squared equals 100 at the point 6, 8. So let's use implicit differentiation in answering this one. Now take note, when you sketch the circle x squared plus y squared equals 100, the radius there is 10. So this is the circle. Then take note, the point of tangency is at 6, 8. So that would be 6 and 8. So it is located in the first quadrant. So let's identify the slope of this tangent line here. So take note, you're given x squared plus y squared equals 100. So get the derivative of this. So derivative of x squared is 2x. Derivative of y squared is 2y dy dx. And derivative of 100 is 0. So transfer 2x to the other side and divide the entire equation by 2y. So we will end up with dy dx is equal to negative x over y. So take note, making use of the point 6 and 8, negative x, so that would be negative 6, then our y is 8. So simplifying this, the slope here is negative 3 over 4. So take note, it's negative, and when you look at this one, the line here is also a falling line. So take note of that. Okay, now let's have this, derivatives of transcendental functions. So with this, let u be a differentiable function of x. So the derivative of e to the power of u, so that would be e to the power of u times du dx. So that's derivative of u here. Another. So derivative of b to the power of u, so you copy b to the power of u times the natural log of the base, then derivative of the exponent tu dx. Okay, another. Derivative of the natural log u, or ln of u, is equal to 1 over u times du dx. So derivative of u. Next, we have here derivative of the logarithm of u with respect to b. So that would be 1 over u natural log of the base times du dx. So please take note of this. So let's have examples. Okay, now derivative of natural logarithmic function. So again, if you're given y is equal to ln of x, so rewrite this as e to the power of y is basically x. So differentiate implicitly. So we will differentiate both sides. So again, derivative of e to the power of y, that's e to the power of y. And derivative of y is dy dx. And derivative of x, we will get 1. So again, eliminate e to the power of y by dividing both sides by e to the power of y. So with that, derivative here is 1 over ey. So take note, the derivative of ln of x, that's basically 1 over x. So let's have this. Find the derivative of ln of 5x. So with this, take note, we have here 1 over x, so that would become derivative of y is dy dx, then 1 over 5x times derivative of 5x is 5. So simplifying, we will cancel 5 and 5. So derivative here is 1 over x. Okay, another. Now, find the derivative of the natural log 2x squared plus 5. So again, derivative of y is dy dx, then 1 over 2x squared plus 5, and the derivative of 2x squared plus 5, that's actually 4x. So since the derivative of 5 is 0. So simplifying further, our answer is 4x over 2x squared plus 5. Derivative of logarithmic function. Now, given y is equal to logarithm of x to the base of b, rewriting this to exponential form, this would become b to the power of y is equal to x. Now, getting the derivatives to both sides, or implicit differentiation of both sides, derivative of by is by, natural log of b, and derivative of y here is dy dx, and derivative of x is 1. Now, at this point, factor out dy dx and divide the entire equation by b to the power of y, ln of b. So at this point, you can cancel this. So with that, derivative of this one would become 1 over b to the power of y, natural log of b. So again, derivative of logarithm of x to the base of b is equal to 1 over x natural log of b. So let's have an example. Find the derivatives of the following. Number 1, y is equal to logarithm of 5x squared plus 4 to the base of 3. So again, derivative of y is dy dx. This would become 1 over 5x squared plus 4, natural log of the base 3, and derivative of this one is 10x. So simplifying further, this is our final answer. Okay, another. Y is equal to logarithm of 6x plus 1 to the base of 2. So again, derivative of y is dy dx, and this would become 1 over, copy this, 6x plus 1, and natural log of the base, which is 2. Now, derivative of 6x plus 1 is 6x. Simplifying further, this is our final answer. Okay, another. Given y is equal to 5 to the power of x. Take note, 5 to the power of x is no longer logarithmic, but instead it is exponential. So with this, derivative of y is dy over dx is equal to 5x times the natural log of the base, which is 5. Derivative of inverse trigonometric functions. So let u be a differentiable function of x. So derivative of inverse of sine of x is equal to 1 over the square root of 1 minus x squared times du over dx. Then for arc cosine, you'll get this. For arc tangent, this is the derivative. Then for arc cot, this is also its corresponding derivative. Then for arc secant, and this is for arc cosecant. So let's start. Let's have this. Given y is equal to arc tan of x. So with this, we can rewrite this as tangent of y is equal to x. Now, differentiating implicitly both sides. So derivative of tangent y and derivative of x. So take note, derivative of tangent is secant squared y times derivative of y is dy dx. Derivative of x is 1. So dividing both sides by secant squared y, we will end up with dy dx is equal to 1 over secant squared y. Now take note of the Pythagorean theorem identity, which is secant squared y minus tangent squared y is equal to 1. Or we can rewrite this as secant squared y is equal to tangent squared y plus 1. Now, since we have here tangent y as x, we can replace tangent squared y here as x squared. So, making use of the derivative of arc tan, which is 1 over secant squared y. So, we can have here as 1 over, replace it with x squared plus 1. So, that's how the derivative of arc tan is obtained. So, let's have an example. So again, this is for arc sine and cosine, this is for arc tan and arc cot, and this is for arc secant and arc cosecant. So y is equal to sine negative 1 of x squared minus 2. So again, derivative of y is dy dx. Derivative of arc sine is 1 over the square root of 1 minus the value here, which is x squared minus 2, then squared times the derivative of this, which is actually 2x minus 0, or simply 2x. So simplifying, we will get this. So squaring the denominator here. So square the first, that's x4. Multiply the first, the second, and 2, that's negative 4x squared. And the square of negative 2, which is 4. So simplifying further, this is negative x4. Negative of negative, that's plus 4x squared, then 1 minus 4, that's minus 3. Okay, another. Okay, y is equal to tan negative 1, 6x. So again, derivative of y is dy dx. Derivative of arctan, so we'll make use of the first red equation here. So that would be 1 over 1 plus, this is x squared, so that would be 6x squared times the derivative of the angle here, which is 6. So simplifying, we will get this one. Okay, then that's one. Third example, y is equal to secant negative 1 or arc secant of 4 minus 2x. So derivative of y is dy dx. Derivative of secant arc secant, so make use of the first blue equation. So that would be 1 over x, which is 4 minus 2x, and the square root of 4 minus 2x squared minus 1 times the derivative of this, which is negative 2. So simplifying, we will get this. So squaring this one, this would be 16 minus 16x squared plus 4x to the power 4, then minus 1. Simplifying further, we will get this, combining like terms, and our final answer here is negative 1 over 2 minus x times the square root of 4x4 minus 16x squared plus 15. So we factor out 2 here, then we cancel. So this is the final answer. Okay, another. Now this one is 3 to the power of y is equal to arc secant of x minus arc cosine of y squared plus 1. So again, derivative of 3y, that's 3y, ln of 3, derivative of y is dy dx is equal to, now for secant, that would be 1 over x, then square root of x squared minus 1. Derivative of x is simply 1. Then minus derivative of arc cosine, that's negative 1 over 1 minus y squared plus 1 squared times derivative of this is 2y dy dx. With dy dx term, we transfer it to the other side. So from here, this would become negative 1 over 1 minus y squared plus 1 squared times 2y dy dx, and this one here at the other side. Okay, then you factor out dy dx, so what's left is 3y ln of 3. Then this one times 2y is equal to this one. Then at this point, divide the entire equation by this. So the final